Okay, this is part 2. I'm going to go over the rest of the examples, starting from number 8 here. Let's get to it. Alright, if you notice, you got a 60-degree angle here, which means you got a 30-degree angle up here. And the pattern for 30, 60, 90 special right triangles is, in the notes, it said that the S side, or the short side, was across from 30. Across from the 60 was the S square root 3 side, and across from the 90 was the 2S side. So to figure out the S side, I just cut this in half. I cut 12 in half, so I found out that this is 6. To figure out the X side, which is the S square root 3 side, well, if S is 6 and it's supposed to have a square root 3 next to it, then I just figured out the answer for X. Again, you could have done trig, but it would have taken longer and to save time. I'm not going to do trig. Just look at your 8.3 notes for more examples for the for number 7, 6, 7, and 8. Okay, a ship's sonar finds that the angle of depression to a wreck on the bottom of the ocean is 13.2 degrees. Okay, I'm going to have to draw a picture. So we got a boat. And here's my terrible boat. Look, I'll draw a little sail. Oh. Okay. If a point on the ocean floor is 75 meters directly below the ship, how many meters is it from that point? Okay, so 75 meters directly below the ship. How many meters is it from that point on the ocean floor to the wreck? Okay, so the wreck's out here, and you're on the ship, and you're looking down to that point. So the shipwreck is here, and you're on the boat up here looking down. So we're looking for this side right here, not the bottom floor, because the bottom represents the floor of the ocean, and we're not down in the ocean. No, we're up on the boat. So the angle of depression is 13.2 degrees. So I'm going to put 13.2 up there. And now let's just label. I know that it's depression because depression is going down. So if you were standing on top of the triangle looking down, that's how you know what it is. If you're down here where the blue dot is, you'd be looking up. That's the angle of elevation. Okay. Excuse me, just going to do a big yawn. 75 is adjacent to my angle. X is the hypotenuse, because I made an L here earlier, so that means the right angle's there. So that means I'm going to do cosine. Alright, so ka toa, ka, and I got the ah, so I'm just going to go cosine of 13.2 degrees equals adjacent over hypotenuse 75 over x. Okay, so you got to remember, if the letter's on the bottom or the number's on top, if you were to throw this other side over 1, you're cross multiplying 75 times 1 divided by x. So you just need to type in divided by x divided by cosine of 32. You just need to type in 75 divided by cosine of 13.2. Did I say 32 earlier? It doesn't matter. Okay, so got my calculator open, and 75 divided by cosine 13.2 is about 77.04. So I guess, yeah, that's how far away you are from the wreck. Okay. Excuse me. Find the angle of elevation of the sun if a building is 125 feet tall, casts a shadow of 196 feet long. Okay. So So you got the sun shining over here. Yay. You got a building, I guess, it's over here. And it's casting a shadow. Ooh, so look, I made a right triangle. A terrible one. Let's make this slightly better. Okay. Find the angle of elevation of the sun. Angle of elevation will be look at this way. If a building is 125 feet tall, 125, cast a shadow 196 feet long. So I'd measure the shadow on the ground. So I know two sides. What sides do I know? I know this is opposite. I know this is adjacent. So I'm going to do inverse tangent, TOA. I'm doing inverse because I know two sides and I'm looking for an angle. So inverse tangent, opposite over adjacent. 125 over 196. I get about 52.48 degrees. Alright. For each triangle, find the missing side length. These are all Pythagorean theorem ones. You just got to go 50 squared plus 40 squared. And hey, you're taking the square root of that. So it looks like my answer is going to be the square root of 4100. You can type that in to get the decimal on your own. I just want to march through these. I know the C, so I'm going to go 250 squared minus 240 squared. And remember, you're going to square root your answer, so I can type it in like that if I wanted to. That gets me the square root of 4900. And the square root of 4900 is 70. So there we go. Okay, this one gave you a similar example earlier. This is 5. This is 12. How do I know that's 5? I just cut 10 in half. This is a Pythagorean triple, which I went over in 8.2 notes. I know that side's 13 just by looking at it because I had that memorized. But 5 squared plus 12 squared equals 169. And you got to square root your answer. The square root of 169 is 13. So there's the math answer. And if you knew your Pythagorean triples, it's that fast. Given the three sides, determine the length of make a triangle. So classifies right, obtuse, or acute. Just remember, you got to square a squared plus b squared, and then you got to square c squared, or c. And if that's bigger than a squared plus b squared, it's obtuse. If it's smaller, it's acute. And if it all equals each other, then it's just right. So it's a right triangle. And remember, C is the biggest number. So I'm going to put a C above 48. I'll put a C above 33.54. And then I'll put a C above 97. And so I'll a squared plus b squared, the other smaller numbers. And then I'll square C separately and see if it's bigger or smaller or just right. Okay, I typed in 46 squared plus 42 squared, and then I typed in 48 squared. And 48 squared is smaller. Excuse me. So this is acute. Oh, and I forgot to check. Given the three sides, determine if it can make a triangle. You just had to add up 46 plus 32 to see if it was bigger than 48, which they are. 15 plus 30, is that bigger than 33.54, yeah, they are. Is 65 plus 72 bigger than 97? Yes. So all three of these can make triangles. I just need to square these other pairs. I need to square 30 and 15, and then square 65 and 72, and square the C numbers separately. Okay, so this one's kind of unique because this one makes 1125, and then 33.54 is 1124.93. So technically this is bigger, so that would make this acute. But I mean, you could argue that it's supposed to be a right triangle. That 33.54 is just kind of a rounded number. But working with just these exactly, this one's acute, and just by a very small margin. Okay, so let's type in 97 squared. I get 9409, and then let's type in 65 squared plus 72 squared. I get 9409. See, it equals that exactly. So that is a right triangle. So looks like I didn't have any obtuse examples over here. This last batch, they're 45, 45, 90, and then the next row down is 30, 60, 90. Check the 8.2 notes. No, 8.3 notes, sorry. For more examples of these. But yeah, you could do trig to figure them out, but it's really much easier learning the special right patterns. 45, 45, 90, the two sides are small, so the other side is the L square root 2 side. These are the L sides. So my answer is 4 square root 2. That's 3 square root 2. It's across from the right angle, so it's the L square root 2 side. So therefore L must be 3. So that means M is 3. Okay, I got 6 square root 2. Alright. 30, 60, 90. So this is my S. This is my 2S. So W is 2 times 2, so W is 4. And then M is my S square root 3. So if S was 2, then S square root 3 is 2 square root 3. And 21, let's see, 30 is looking at M, which is your short side, S. 90 is looking at 6, which is 2S, which means M is half of that, so 3. And W is the S square root 3 side, so if S was 3, then my answer is 3 square root 3. Alright, and then the last one is, let's see here, I got 60 looking at 4 radical 3, so that's S radical 3, which means S is 4. If this is 30 degrees, that's looking at M, which is the S side, so that means M is 4. W is the 2S side, so I just need a double 4, I get 8. And that's it for the Chapter 8 review. Hope this helps. Bye.